All right, everybody. Thanks for once again bearing with me through another video notes session. Fortunately, I am out. Um, Something happened with my family, and I'm not going to be there on Monday. So I will be there Tuesday, no problem. So I will see you guys then. But I will not be there tomorrow on Monday. All right, so today's set of notes are a little long, and that's okay. I'll try to get these done as soon as I can, or as fast as I can, and they're not too bad. So right now, it's just a lot. What we're going to be learning is classifying triangles. So there's a few different types of triangles. The first one is an acute triangle, and this is if all. Oh, let me change this up. That is if all angles are acute. What? You can't use a definition um, of something to define something, right? So to define itself. But for an acute triangle, if you guys remember, um, acute angles are any angles that are less than 90 degrees but more than zero. So if we had a triangle, let's make it look something like this, right? And in this triangle, let's say we had 85 or 75 degrees in here. And then we have 85 degrees up here. And then we add 20 degrees over here. I know, bear with me, it's not the best looking triangle. That's okay. Um, Excuse me, I just sneezed. If we had this triangle, this would be an acute triangle. So all the angles are acute, right? Less than 90 degrees. Let's say theta is less than 90, but more than zero, right? So that's an acute triangle. If a triangle has one right angle, then my triangle would look something like this, and you'd have a 90 degree. And let's say that the other one is, I don't know, 57 and 33. All right, this would be a right triangle. It has one right angle, so it's a right triangle. Um, Obtuse is, if you guys remember, is anything that is greater than 90 but less than 180. And so this is if it has one obtuse angle. So if a triangle has one obtuse angle, let's make it look like that. That's fine. And this is 142 degrees. Let's say this is 15 degrees and 23 degrees, then this would be an obtuse triangle. And then an equal angular triangle is a triangle that has all angles that are congruent. Congruent, remember, just means all are going to be the same. And if we divided a triangle into three equal pieces, right, we would know that this would be 60, 60, and 60. So these are all, this is an equal angular. It's the only way of having it. 60, 60, 60. All right. Um, Now, that's classifying the triangles by its angles. Now we're going to go ahead and classify triangles by their side length. So scaling means that they have no congruent sides. No congruent sides. So we just have a triangle. Doesn't really matter what it looks like as long as it's a triangle. There we go. Right? None of them are the same. Then this is a scaling triangle. No congruent sides. All different. Isosceles means that you have two equal sides. And we'll just do this so we remember. Two equal sides. We have two congruent sides. And an equilateral triangle is obviously similar to equiangular, where every side is congruent. So all congruent sides. So scaling is none, isosceles is 2, and equilateral is 3. The way that I like to remember, I know this is really weird, is um, I know this is isosceles, eyes, uh, isosceles, right? Most normal people have two eyes, not Mr. Martinez, though. So most normal people have two eyes, and so the way that I remember isosceles is that we have two eyes and we have two equal sides. So, or angles, but we'll get there when we get there. All right, let's practice. Let's classify each triangle by its side lengths. Well, notice we've got two equal sides. So by sides, this is an isosceles. That's what it is. If it has two equal sides, it's an isosceles. Every single angle is less than 90, so therefore it is an acute isosceles triangle. Here, every side is different, so this is a scaling. And we've got one right angle, so this is a right scaling triangle. Notice every single side is the same, every angle is the same. So this would be an equilateral, equiangular triangle. And generally, if you're going to be equilateral, you're also going to be angular. Make sure you don't mess those up. Do not shorten these. Keep these as is, right? Because you can't put equa and assume that I know that you know what you mean. If it's sides, equal lateral. And then if it's angles, equal angular. All right, here we go. One more. We got two equal sides. So this is isosceles. 90-degree angle. We have a right. We're done with that. Take a second to take a look at that. And it's that simple. But let's keep going. Now, with one of the most, I mean, you're going to see this a lot, right? So it's very prevalent, are isosceles triangles. And they're kind of special where not only do they have two equal sides, but they also have two equal angles. And generally, those are going to be your base angles because this is just how we draw them. Sometimes they can be a little tilted or on a different side, but the base angles are going to be the ones that we generally say are congruent, right? Just so that like we have this triangle here that's just standing up on its base where the two, the left and the right side there are going to be congruent. So base angles are two angles adjacent to the base. And that's it. That's pretty much it. So this is my base, right here. And these are adjacent to it. So it's not the base. And those are my, these are adjacent sides. But these here are adjacent angles. Let me change the thickness here. These are going to be adjacent angles. And those are going to be congruent. These are going to be congruent. Let's put it on the side here. Vertex angle is here, right? It's a cross, so it's essentially the angle that's formed by the two legs. Angle by the two congruent legs. And that's a vertex angle. So in this case, it's A. The base is the non-congruent side opposite to the vertex angle. So essentially, this is the vertex. This is opposite. So the base here. Um, these are the non-congruent side, right? Because it is not the same as the other two, and it is opposite of the vertex angle. And then obviously the legs are the two congruent sides here and here. Legs are two congruent sides. I don't know why I'm writing congruent instead of doing the congruent symbol, but it's okay. So let's keep going. Let's look at some theorems. Isosceles triangle angle. Side theorem. Given sides, right? If two sides are congruent, then the angles opposite to them are congruent. So the short version is if we have a triangle, right? So if we have a triangle, that was terrible. Then the two sides are congruent, then its opposite angles. Fix this. And its opposite angles are going to be congruent. So that means if I give you this triangle and I tell you, hey, these two sides are congruent, then the angles are going to be congruent. The opposite angles. So the base angle is there. If sides congruent, then angles congruent. If two angles are congruent, then the sides opposite to them are congruent. So again, if we have now these angles being congruent, then the opposite sides are going to be congruent. And it's the same thing, it's just a converse, right? So if, boom, 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 come on. Sometimes my triangles work, sometimes they don't. If angles are congruent, then sides are congruent. So it's just the opposite. It's just the converse of what we just learned. If angles are congruent, then sides are congruent. Let's keep going. Equilateral and equiangular triangles. Equilateral, well, if you guys remembered already, this means all congruent sides. Equiangular means all congruent angles. If a triangle is equilateral, then guess what? It's also equiangular. And the converse is also true. If a triangle is equiangular, then it is equilateral. So if I have all equal sides, then we will have all equal angles. And if we have all equal angles, then we will have all equal sides. Or all congruent sides, I should say. This is another one of my special triangles. We're almost done. We got 4 problems left, and then we're done here. Okay. Solve for x and or y. Notice that here they are telling us that all of these sides are congruent. So that means what we got to do is we got to start setting some of these equations equal to each other so that we can solve for our congruent sides, right? Um, so let's take a look. Notice that here I also have an x, and that's not really going to help me too much yet. But I do see that I have a 4y plus 12, and I have a 6y there. Same exact variables, so I'm going to go ahead and use those for 6y is equal to 4y plus 12. That is true. Let's go ahead and solve for y. I'm going to go ahead and subtract 4y. I get 2y is equal to 12 divided by 2. Y is equal to 6. Now, if we find one side, we're going to be able to find all sides, right? So if y is equal to 6, then therefore 6 times 6 is equal to 36. So all of these angles are going to be 36. But that's not what we're looking for. We're not looking for the sides. We're looking for the x and the y value here. So now, though, I do know that 10x minus 4 is equal to 36. So let's go ahead and solve. I add 4. I get 10x is equal to 40. Divide by 10x is equal to 4. And that was it. So simple, right? Not too bad. Number 2 is an isosceles triangle. This is going to be a little bit more work. That's okay. I know that this side here is congruent to this side here. So let's set them equal to each other. I'm going to put the quadratic side first. So x squared minus 5x minus 15 is equal to 13 minus 2x. Now remember, whenever you have some quadratic like this, we do have to set one of the sides equal to 0. So I'm going to go ahead and subtract 13 and add 2x so that all this just becomes 0. And if you guys are still having issues with quadratics, I did explain why this whole thing works in the previous video. So it was my last video right before this one for our class. So we have x squared minus 3x minus 28 is equal to 0. So now you guys can use your x method. I like to use my table, right? So negative 28. And we start finding things that multiply to negative 28 and add up to negative 3. And remember, this is only the case because this is my a value here is 1. So I know the big number has to be negative. 1 and negative 28, too big. 2 and negative 14, too big. 3, 4, and negative 7. Hey, that adds up to negative 3. So from here, we're just going to do x plus 4, x minus 7, and this is equal to 0. Set both things equal to 0. X plus 4 is equal to 0. Solve. X minus 7 is equal to 0. Solve. And we get x is equal to negative 4. X is equal to 7. 2 answers right there. But do they both work? Have no idea yet. Let's go ahead and plug them in. So let's use the easier one on the side here. Sometimes we got to check them all. But actually, no, not all the times. Because if one side is negative, then all sides are going to be negative, or at least the other side is going to be negative because they're congruent. So you will have to check at least one side there, and very often the base. But let's check. I'm just going to check the one on the left there. So we have 13 minus 2x, but remember x is no longer x. It's going to be, let's put the negative 4 in. Oh, well, actually, I can already tell that this is going to be positive, right? 13 plus 8 equals 21. So negative 4 actually works. So very often, I've told you guys, don't assume that just because it's negative, it won't work. And 13 minus 2 times 7. This is negative 1. We cannot have a negative side length. So x equals 7 goes away. My only answer here is going to be x is equal to negative 4. That's it. We're done with this guy. So two more. Final angle A is 4x minus 14. Angle B is, actually, I'm not going to write anything here. Um, Angle 14, angle B is 2x plus 8. And angle C is 2x plus 26. We have to solve for x. So let's see if we can figure this out. Okay. I already see that, look, I've got two congruent sides. So that means the opposite sides are going to be congruent. So that means that 4x minus 14 has to equal 2x plus 26. Now, let's just solve. I'm going to subtract away my 2x first. I get 2x minus 14 is equal to 26. Add 14 on both sides. 2x is equal to 40. Again, these are congruent. Divide by 2. X is 20. So we found x. And we use our isosceles problem. The cool thing about this problem here is there was a different way that you could solve for it. Right? We do know that these sides have to be congruent, which is why we set them equal to each other. But if for some reason you didn't remember and you knew your third side, what you could have done, you could have added 2x plus 8 plus 4x minus 14 plus 2x plus 26. And remember, a triangle adds up to 180. So you add them all up to 180, and you should have gotten a nice answer there. But don't always assume it's going to work out nicely, right? It should. Don't always assume it will. So it's always a good idea to do your isosceles. And that is it. All right. Let us keep going. Let us keep going. Here we go. Number 4. Last one, and then you guys are free. Okay. I know that that green angle here, M, is going to be 6x plus 7y. I know that this red angle is 60 degrees. I know this is 14. And this is 2 times the quantity of 2x plus 1. All right. Cool thing. All angles are the same. So that means I can set this side equal to this side, and we can solve. So let's go ahead and use orange for that, right? So I know that 2 times 2x plus 1 is equal to 14. Now, there's many ways that you can solve this. You can distribute first. I'm not going to do that. I'm too lazy to do that. I'm going to go ahead and divide by 2 here. And we got 2x plus 1 is equal to 7. Subtract 1. Divide by 2. X is equal to 3. Found it. I suggest you guys distribute here. Right, make sure you distribute, and you'll notice that when you distribute, you still end up getting the exact same answer, right? Cool thing about math is there's lots of different ways to solve the same problem, and this is just my simpler way, right? Get rid of that 2 times the quantity, and you should be able to then solve for 2x plus 1. All right, we found x. Perfect. Now, let's go ahead and find my angle, my y. So I know that 6x plus y is equal to 60 because although these are different colors, right, this is an equilateral triangle, which means all angles, so that means it's an equal angular triangle. All angles are the same. So I'm going to go ahead and take this. I'm going to set it equal to 60. But remember, actually, let's just take it a step at a time. So 6x plus 7y is equal to 60. Let's go red. But again, remember that we found x. X is 3. So let's go ahead and plug that in. I get 18 plus 7y is equal to 60. Subtract 18, I get 7y is equal to 42. Divide by 7, and we get a final answer of y is equal to 6. Okay, and that's it. We're done. No more. No more Mr. Martinez boring talking to an iPad. So that's it. That's how we would do these. right? Good thing about having a video notes, although they are a drag, is that now you have a replay value, right? So if you guys ever don't understand something, you can always come back and take a look. You can take screenshots and a bunch of other stuff. So thanks a lot, guys. Again, thank you for bearing with me again with another video notes essay, right? I hope to see you guys on Tuesday. Have a great rest of your day. Get that practice done. Thanks.